Now here we're looking at congruent triangles, and two triangles are said to be congruent when one of these conditions is true. Now congruency is not to be mixed up with similar shapes. Similar shapes are where all the angles are the same, and so one shape is an enlargement of another. Whereas congruent triangles are where the two triangles are exactly identical. So exactly same in size, angles, lengths. Okay, so one is not an enlargement of the other. They're exactly the same shape and size, but maybe in a different orientation. So first of all, let's make sure we understand that definition, that triangles are said to be congruent if all the sides, all the three sides and the three angles are equal to each other, not an enlargement. Now we have four conditions under which we can prove that two triangles are congruent. So if all three sides are equal, so that's the first one here that we've got. If all three sides are equal, then the two triangles will be congruent to each other. Okay, so this example of all three sides being equal, as you can see in the diagram, it's this third one that we've got here. I'll just put a number here. Number 1 here matches this number 1 here, where all three sides are the same. Notice here we've got these little lines here indicating. So first of all, we've got this line here, which is equal to that line, so that side and that side are equal. Then we've got these double lines here, which means those two sides are equal. And then we've got these triple marking here, which means that final side is equal to each other. And in that case, both of these triangles are same because all three sides are equal to each other. So we say side, side, sides. So the three sides are three sides match each other. Okay. The next condition we have is where we've got two sides and an included angle. When we say included, we mean the two sides and the angle in between. So let's take a look at which of these triangles fit this description here. So we've got two sides which are matching. So we can see here there's a side and a side matching, another side matching. So those lengths are equal to each other in both of those triangles. And you can see here the angle in between those two sides here are also equal to each other. In that case, we have side angle side. Okay, so that's condition 2, where we have side angle side, where we have two sides and angle included or angle in between, which match. The third case is where we have two angles and a corresponding side which is equal in both triangles. Corresponding meaning the same side on both triangles. So let's take a look at that condition here. So we have two angles and a corresponding side. So we'll label this number 3. We can see here that we've got two angles matching here. This angle and this angle match as indicated by those two lines on the angle, and this angle match. So we've got the two angles. And notice here that this side is opposite to the angle with the two lines, and likewise that side here is opposite to the angle with the two lines. So this is a case where we have angle, angle, side. Two angles and a corresponding side. Notice that this side here corresponds to this side here. Okay, so two angles and a corresponding side. Okay, so that's the third case. And the last case that we have is where we have a right angle, a hypotenuse, and one other side are equal. So if we have a right angle and a hypotenuse and one other side that are equal, then those two triangles are said to be congruent triangles. So this is the case that we have. We can see here we've got a right angle on both of them. So that's that angle, and then we can see that the hypotenuse are equal for both of them. They both have the same single marking indicating those two lengths are equal. And then we've got this other length here, which is equal to each other as well. So this is the fourth case here, where we've got right angle, hypotenuse, and one side, which are equal. So I'll just make a note what this is: right angle, hypotenuse, and one side are equal. So these are the four conditions in which we can show that two triangles are said to be congruent. And let's take a look at how this is applied to a particular question. So this is a typical question that you'd get. You're asked to prove that triangle ABE and triangle CDE are congruent. And we can see the two triangles here. Triangle ABE is the top one and triangle CDE is the bottom one. Now, in order to show congruence, we need to find matching lengths, matching sides, matching angles, and so forth. And then we need to use one of our conditions for congruency to prove this. So first of all, let's look for things which are equal to each other between both triangles. That's the first thing that we should try and do. So notice that I have 110 degrees here, then vertically opposite angles are equal. So this angle here is 110 degrees also. So I'll mark that in. Now, we're told here in the diagram, we can see that the length AB, which has a single marking on it, is exactly equal in length to length CD, which has that single line marking indicating equal lengths. And in addition to that, both of those lengths are parallel. So first of all, those lengths are equal to each other. That's very important. So we've got two lengths which are matching between both triangles. Since we have parallel lines, we can go and use our knowledge of angles on parallel lines to find out maybe other matching angles. So we can say that angle ECD, which is marked as 50 degrees here, we can see, is alternate to angle ABE. So we can go and mark this other angle here, and we can say angle ABE is also 50 degrees. So I'll go and put that in there. So I have that angle as well. In addition to that angle, I can also find the final angle if need be, because we know angles in a triangle add up to 180. So since I know 110 and 50 add up to 160, the final angle here must be 20 degrees. And likewise, this final angle here must be 20 degrees as well. So let's go and see which of our congruency conditions we can use to prove these two triangles are congruent. First of all, I'm going to just highlight matching things that I have. So I've got a matching angle here, 110, and I've got another matching angle here, 110. So I've got an angle. I've also got a second angle here, which I've got 50 degrees, which are both matching. So I've highlighted those. And in addition to that, I've also got a length, which we can see is equal in both of those triangles. And these lengths are both corresponding lengths, because we can see here that these lengths on triangle ABE is the length opposite 110 degrees, and in triangle CDE it's also the length opposite to the 110 degrees. So length AB and length CD are corresponding lengths. So what can I use here? Well, I can use ASA, where we've got two angles and a side. So I'm going to write that down here. ASA, okay, is what I'm using. But I need to go and show that. How have I shown that to each of the angles? So I need to go and prove each of these letters. How have I shown two angles the same? So first thing which I'm going to say is that angle, I'll focus on this first A here. Let's focus on this A here. And I'll say angle AEB is equal to angle CED. Why are they equal? Because they are vertically opposite angles. So I'm going to write down the reason as well. Okay, vertically opposite angles are equal. So write down all our reasons. Next thing I can say is about the side. Let's go and make a point about the side. So we can say length AB, so AB is equal to CD. They are corresponding lengths. Or corresponding sides. And lastly, the final A represents the final angle here. And then the final angle that we've got, as we can see here, is the 50 degrees that we highlighted. So this is angle ABE is equal to angle ECD. And the reason for that is because alternate angles. They're both alternate angles are equal. So we can then conclude, therefore, triangle ABE is equal to triangle CDE through ASA. So that's a complete proof to show that both triangles ABE and triangle CDE are congruent.